Hi, and welcome back to Peak Flicks. This is Math Grade 5 with Mrs. Rossi. I'm so glad that you decided to join us today. So today's learning goals. We are going to be learning how to simplify or reduce fractions. And I know I've spoken to you before about, feeling a little weird about fractions because they're parts of numbers. Okay, but we use them in everyday life. We use them for baking. We use them for measurements for food. Sometimes we use it for measurements for mass or weight. We use them in construction. We use them with shopping. We use them for so many things. So there are a couple of other things I need to talk to you about. Okay, questions for today. What are reduced fractions? Okay, how do I create simplified fractions? A lot of the times the word reduced and simplified are used interchangeably, and they're not exactly the same thing, but they're related. Okay. Again, the question, what does one have to do with it? How can I create one with fractions? And how can knowing prime and composite numbers help me? So prime numbers are numbers that have factors of only one in itself, and composite numbers are pretty much all of the rest of the numbers. So if you know what prime numbers are, especially if prime numbers are in the numerator, you won't have to search for a common factor as much. What are the divisibility rules? You might have learned this over the school year, but there are certain rules to find out what larger numbers are divisible by certain numbers. So for example, a 2. The divisibility rule for 2 is any number that ends in 0, 2, 4, 6, or 8. So essentially any even number that's positive, that's larger than 2, is divisible by 2. And we'll go over that in a little bit. So again, while we're going through, what else can you think of? What other questions do you have that you could ask a friend, a neighbor, an adult, a brother, sister that can help you with these fractions? Okay, so the divisibility rules. I've included them on this slide, and I told you a little bit earlier about the number 2. The divisibility rules would be units ending in an even number. So 0, which is over here, 2, 4, 6, 8, and 0. Also, if it's 3, the sum of the digits is a multiple of 3. So what that means, if we're talking about like 123, we would add 1 plus 2 and get 3 and add that to 3. It would be 6, and that 6 is a multiple of 3. So that 123 would be divided by 3 easily and equally. The divisibility rule for 4, a number is formed by the last 2 digits as a multiple of 4. So if you have a longer number, let's say it's 1,216, since 16 is part of the last 2 digits, then 4 will go divide evenly into that number. Okay, 5 is probably one of the easiest. The unit digit, which is the ones, would be either a 0 or a 5. So like 925 is definitely divisible by 5. And number 9, the sum of the digits is a multiple of 9. Again, if we have a number such as 817, if we add 8 plus 1, that's 9, plus the 7 is 16, that wouldn't work, okay, because that would not be divisible by 9. But if we had like the number 810, where we added 8 plus 1 plus 0, and that it would equal 9. 9 is a multiple of itself, so that would work. And then again, anything divisible by 10 if the units digit is a 0. So these kinds of things are going to help make the fractions a little bit easier if we know how to use these. Let me move my picture over here just a second, and we'll talk about knowing the prime and composite numbers can also help. So prime numbers are numbers that have only themselves and 1 as a factor. And composite numbers are pretty much all of the rest. So knowing that a 7 as your numerator, you're going to be able to narrow down what kind of other numbers you can use very quickly, either 7 or nothing, to simplify those fractions. All right, let's get moving on to our questions for today. Hi, and welcome back. How fast can you be? Today we're going to be dividing using the digit or the number 7. They're a little bit tricky. I'm going to give you a little bit longer today, and let's get started. 42 divided by 7 is equal to It's equal to 6. 56 divided by 7 is equal to, it's equal to 8. 14 divided by 7 is equal to, it's equal to 2. 70 divided by 7 is equal to, I know you know this one, the answer is 10. 0 divided by 7 is equal to, that's right, it's 0. 77 divided by 7 is equal to, it's 11. 35 divided by 7 is equal to, it's 5. 49 divided by 7 is equal to 7. 7 divided by 7, that's equal to 1. 84 divided by 7, use your thinking caps for this one. It's equal to 12. 63 divided by 7 is equal to, keep on thinking. If you said 9, you are correct. 28 divided by 7 is equal to, I know you know it, it's 4. 21 divided by 7 is equal to, if you said 3, kiss your brain. How fast are you? You're improving. I tell you every time that you log on and do the fluency with me that you are improving. So again, practice on your own, use flashcards, go on Reflex Math, whatever you need to do to get stronger, better, and faster. All right, let's get ready to move on to our next thing. See you in a little bit. Okay, so here we are today with our warm-up questions. So we have 48 100ths, 13 19ths, 8 4/10ths, and 3 33rds. Okay, I'm going to get started on a separate sheet of paper, but there are 3 questions that I kind of want to think about. Am I doing this correctly? So I need to make sure I'm following that same procedure for each one. What can you look for? So we're really looking at, do we know right away what number can we divide by to get the simplest form or to reduce these fractions? And how does this work? Sometimes you're going to want to leave your numbers or your answers that you get how they are. And some of them, especially if they're being asked for you to reduce them, you're going to want to do that. So join me in just 1 second on the side paper and I will show you how this is done.
Thank you for joining me. So we're trying to reduce 48 100ths. So what I can do is list all of the factors for 48 and the factors for 100 that I can think of to make this problem go a little bit easier. So I'm going to make my T-chart over here, 48 and 100. I'm going to start with 100 since I know a little bit more about that. So I'm going to put 1 and 100. I'm going to put 2 and 50. I'm going to put 4 and 25. And I'm going to stop there. For 48, I'm going to do 1 and 48. I'm going to do 2 and 24. And I'm going to do 4 and 12. And right now I see that I have 4 common between the 2 of them, and I'm going to actually go ahead and use that 4. So again, I'm going to divide by 4/4, which this is the same thing as dividing by 1, as I don't want to make I want to reduce the fraction, but I also want to keep it equivalent. So 48 divided by 4 is going to give me 12, and 100 divided by 4 is going to give me 25. Now, I'm going to look at 12 25ths. Can I make 12 25ths smaller? So again, if I'm worried that this is not the most simplified, I can go back and I can list the factors of 12 and list the factors of 25. So the factors of 12 are 1 and 12 and 3 and 4. and 2 and 6. And the factors of 25 that I know of are 1 and 25 and 5 and 5. So I don't see anything common between them besides 1, and that doesn't really help me out. So my simplified form of 48 100ths would be 12 25ths. Okay, moving right along, we are going to be now looking at 13 19ths. Now this is where the case of knowing your prime numbers is going to come in handy, because if you know about 13 and 19, you'll know that those two are both prime numbers. The only way that I can make 13, if I make my T-chart here, is 1 and 13, and the only way to make 19 is 1 and 19. The only thing common that I have between the two of them is 1, so 13 19ths is actually already in simplified form. In this question, 8 and 4/10, I don't really need to do anything with my whole number. I can't reduce a whole number, so I'm really just going to be focusing on the 4/10. So over here, I'm going to do my T-chart again. I have 4/10. The only way to make 4 is 1 and 2 and 4, and the way to make 10 is 1 and 10 and 2 and 5. So my common factor, my greatest common factor, is 2. So again, I'm going to keep the 8 by itself, and then I'm going to just take that 4/10. I'm going to rewrite it over here, and I'm going to divide it by 2 over 2, or 1. 4 divided by 2 is 2. 10 divided by 2 is 5. So I'm just going to take this answer, which is the 2/5, and change 8 and 4/10 into 8 and 2/5. And now my answer is in simplest form. Okay, my last question is 3/33. 3 is a prime number. It's actually the smallest prime number. And I'm going to use 3 as my divider, or what I'm going to divide with, because I know that 3 is prime, and I also know that 3 can divide equally into 33. So I'm going to go ahead and do that math. I'm going to put 3 over 3, which is the same thing as like dividing as 1. 3 divided by 3 is 1. 33 divided by 3 is 11. So 1/11 is the simplest form of 3/33.
Okay, now that we've completed those questions, we are going to be taking a look at a real-life problem to see if we can solve it. Let's read together. 21 students went to the field library during book reporting time. 6 students read about animals. What is the simplified fraction of the amount of students who did not read about animals? This one is a little tricky. I'm going to take a few minutes, read it one more time, and then we'll solve it together on our side paper. Okay? We're also going to make sure that we give our answer and our statement of solution and be able to explain our thinking. This one is a little tricky, so let's read it one more time together. 21 students went to the field library. During book reporting time, 6 students read about animals. What is the simplified or reduced fraction of the amount of students who did not read about animals? So for this one, I'm going to have to be doing a little bit of math, a little bit of thinking, and to figure out what numbers am I going to isolate to try to find my answer. Okay? Again, I'll be doing my work on a side paper, and I will reveal the answers once we're done.
All right, let's get started on this problem. 21 students went to the field library during book reporting time. 6 students read about animals. What is the simplified fraction of the amount of students who did not read about animals? Explain your thinking and include a statement of the solution. So I'm going to look at the numbers that I do know about, okay? What is the simplified fraction of the amount of students who did not? This is the word I want to cue in on, not. Did not read about animals. So out of the 21 students, okay, some read about animals, some of them no animals. Okay, and you might be familiar with a number bond here. So 6 read about animals. So another number read about something else besides animals. So I'm going to take 21 and subtract 6. and I'm going to say that 15 did not read about animals. Now, I'm pretty sure that my answer that I have, 15 21st, is a pretty good answer, but it asked me for the simplified fraction. Okay, so the simplified fraction, I need to look at, can 15 21st be simplified? So what I'm going to do is the same process that I've done for my other simplification problems, and I'm going to make my t-chart. So 15 and 21, what are the factors of 15? Well, they are 1 and 15 and 3 and 5. And for 21, it's 1 and 21 and 3 and 7. So the greatest common factor between the two of them is 3. So I'm going to go ahead and I'm going to divide 15 21st by 3 over 3 to simplify that fraction. So 15 divided by 3 is 5. 21 divided by 3 is 7. I know that 5 is a prime number. I know that 7 is a prime number, so I'm happy with this answer. So I'm going to go ahead and write the statement of the solution. 5/7 of the students did not, I'm going to underline that not, read about animals. Okay, so I'm going to go back and just explain to you how to do this problem. So we started out with the 21 students total, 6 of them reading about animals, and the rest reading about not animals. So on the side over here, I did 21 and subtracted 6 to find the unknown 15, which is the no animals. And so then I made this fraction, 15 21st. The 15 was the kids that read books other than animals. And the 21 was still the total, which I left here. Then I made the t-chart listing the factors of 15 and 21 and find the greatest common factor is 3. So I divided by 3 over 3, which is like dividing by 1, and I got 5/7. So then I wrote my statement of the solution. 5/7 of the students did not read about animals. And that's it. Let's move on to our next question.
All right, thank you for going through that with me. Let's move around to the question that you're going to be doing on your own. So, you have been to Hillcrest School, probably. And we have this beautiful new courtyard, and we have bird feeders there. So let's read a question about what's going on with these birds. 12 birds were eating at the bird feeders in the MBK courtyard at Hillcrest. 2 birds flew away. What fraction of birds still remained? Please give your answer in the simplest form. Explain your thinking and include a statement of the solution. So for this one, you're going to pause the video. You're going to figure this out on your own. And then when you're ready, you're going to unpause the video and I will take you through the problem and reveal the answer in the statement of the solution. All right, please pause the video at this time.
So 12 birds were eating at the bird feeders in the MBK courtyard at Hillcrest. 2 birds flew away. What fraction of birds still remained? Please give your answer in the simplest form. Explain your thinking and include a statement of the solution. So I like to think about this in terms of a picture, right? So I have 12 birds there, okay? And then it said 2 birds flew away. So that tells me I'm doing 12 minus 2. So that means that there's 10 birds left, okay? What fraction of birds still remained? So that word remained is talking about this 10. But we're not trying to give our answer in just a regular number. We're trying to give it as a fraction. What fraction of birds still remained? So there was 12 total, so that's going to be my denominator. And the 10 out of the 12 still remained. And then I have to give my answer in simplest form. So simplest form means I need to find out if 10/12 is as simple as it can be or not. So using my rules of divisibility, I see that they both end in an even number, and I'm pretty sure they both can be divided equally by 2. So I'm going to go ahead and do that. I'm going to divide by 2 over 2, or divide by 1, because that's what that would end up being. 10 divided by 2 is equal to 5. 12 divided by 2 is equal to 6. Okay? Now in my answer, 5 I know is a prime number, so I know that they can't get any simpler as far as the numerator, and 6 can only be divided by 1, 2, and 3, so I'm good to go here. So I'm going to go ahead and give my statement of solution. 5/6 of the birds still remained at the MBK feeder. And I'm pretty happy with that answer. So explaining my thinking, I'm going to go ahead and tell you all of the math that I did here. So I took 12 and I subtracted 2. The 12 was how many birds in total. The 2 is how many flew away, giving me the answer of 10. So 10 out of 12 remained, which was this answer. And then I divided by 2 over 2 to get my simplified answer, because it asked for simplest form. So when I divided by 2 over 2, I got 5/6. And then this is my statement of the solution, my answer. Okay, 5/6 of the birds still remained at the MBK feeder. Okay, you did a great job on this question. Kiss your brain and get ready to do some reflex math or some Zern, and definitely do not forget to do that exit ticket.
All right, Peak Flicks math scholars, you have done an incredible job today. But you're not done yet. I'm going to need you to go on to Zern, Reflex Math, or most importantly, fill out an exit ticket for today's work. Please show us how smart you are and what you have learned from doing the lessons here on Peak Flicks. Thank you so much for your time, and we look forward to seeing you tomorrow. Have a great day. It was wonderful teaching and learning alongside of you. Take care.